The allure of knowledge and the promises it holds. The allure of knowledge and the promises it holds have captivated humanity for as long as we have been able to think, walk on two legs, and harness fire. From the earliest cave paintings to the first songs ever shared, our species has always been motivated to investigate, create, and progress. Over centuries and millennia, we evolved, not only physically, but also mentally and spiritually. After millions of years of evolution, humanity has reached its current stage of growth and understanding. Over time, we have found answers to numerous questions that once eluded even the greatest historical thinkers, scientists, and philosophers. These mysteries have gradually been solved by the scientific community, one after another. With each discovery, fewer and fewer things seem impossible. Communication has become instantaneous. Diseases are being cured. Transportation, once slow and time-consuming, is now rapid and efficient. Yet in spite of these advancements, a lingering question remains. When did it all begin? If you're curious about the beginning of time itself and the latest discoveries about our universe, don't forget to like this video, subscribe to our channel, and hit the notification bell to stay updated. Theories of the universe's origin. Throughout history, various theories have emerged regarding the origin of the universe. One of the most widely accepted is the Big Bang theory. According to this theory, the universe was once compressed into an infinitely small point in time. This point began to expand, eventually giving rise to the vast cosmos we observe today. It wasn't until later that astronomer Edwin Hubble made a significant contribution through his study of galaxies. He observed that the farther away a galaxy is, the more rapidly it seems to be moving. This supported the hypothesis of an ever-expanding universe. Hubble's findings suggested that before the Big Bang, the universe consisted of tiny, hot particles mixed with light and energy. After the expansion, atoms began to cool and form. Galaxies were formed over billions of years, giving birth to the cosmos as we know it today. The James Webb Space Telescope, JWST. In 2021, the James Webb Space Telescope, the most expensive and advanced telescope ever built, was launched into space. It captures infrared light, allowing it to peer farther into space than any telescope before it. Positioned over 1 million kilometers from Earth, the JWST has unparalleled power to capture images and process data. As astronomer Neil deGrasse Tyson has pointed out, the further the JWST looks, the further it looks back in time. Initially, the telescope was expected to confirm the Big Bang theory, but its first images raised some intriguing questions. Galaxies visible in JWST's images appeared small, smooth, and remarkably old, contrary to what many scientists expected. Challenges to the Big Bang theory. You might wonder how this challenges the Big Bang theory. The JWST images show galaxies that should be farther away appearing smaller in size. This contradicts the expectation that galaxies farther away should appear larger, due to the optical effects of looking back in time. Some of these galaxies also exhibit redshifts 2 to 3 times higher than anticipated. One of the most puzzling images depicts a group of galaxies all appearing the same size, raising questions about whether the universe is expanding at all. If the Big Bang theory is correct, galaxies should be smaller the further away they are, to account for the optical illusion of expansion. Additionally, some of the distant galaxies shown in JWST's images look surprisingly smooth. Current theories suggest galaxies should collide and merge, resulting in galactic scars or distortions, a phenomenon known as Mighty Mouse galaxies. Yet the JWST depicts galaxies that are unusually smooth, suggesting mergers may be far rarer than expected. These observations challenge the idea that galaxies grew large through frequent mergers. The discovery of what appear to be billions of very old galaxies raises further concerns. If these galaxies have existed for so long, they should have already been consumed or transformed through cosmic processes. According to the Big Bang model, we should see fewer galaxies as we look deeper into space. But the JWST has captured images of more galaxies, and larger ones than expected. This raises a critical question. How could so many large galaxies form in so little time? Many scientists find this highly improbable. An alternative theory: plasma filamentation. There is, however, an alternative explanation: the plasma filamentation theory. This theory, around for more than 5 decades, suggests that electric currents and their associated magnetic fields stimulate and pull plasma into filaments found throughout the universe. Plasma filamentation is recognized as a key process in the formation of stars, planets, galaxies, and other cosmic structures. When large clouds of gas and dust are pulled together by gravity, they can collapse and form a protostar at the center. This collapse is often aided by plasma filaments, which help support the cloud by transferring energy and momentum. Once a star forms, it may have a surrounding protoplanetary disk made of gas and dust, from which planets can form. Plasma filamentation influences the dynamics of this disk. Although not directly responsible for planet formation, the theory also informs efforts to artificially generate fusion energy, a process still in its early stages but with vast potential. Whether plasma is the key energy source of the universe or simply a part of it, filamentation may help us unlock its secrets. The ongoing mystery of the universe. Understanding how the universe was made is still a mystery. Ongoing research may bring new hypotheses, but for now, much remains speculative. As we continue exploring the mysteries of the universe and the origins of everything we know, one thing becomes clear: the pursuit of knowledge is an endless journey. Our understanding of the cosmos has advanced significantly over time. Yet, for each new answer, more questions arise. While the Big Bang Theory has long been the leading explanation for the beginning of the universe, the latest findings from the James Webb Space Telescope have cast doubt on some of its core assumptions. These revelations remind us that science is not static, it is a dynamic field, constantly adjusting in response to new evidence. The JWST, with its unprecedented capabilities, has given us images that challenge what we thought we knew about the universe. Galaxies appear smaller and smoother than expected, an observation that defies conventional understanding of galactic formation. If the universe is indeed expanding, as the Big Bang Theory suggests, then galaxies should appear larger the farther away they are, not fewer. This inconsistent behavior has led some researchers to reconsider whether the expansion of the universe is occurring as we have always believed. Simultaneously, the lack of evidence for galaxy mergers poses yet another challenge to the theory. According to it, galaxies should collide and merge, leaving behind scars of their violent past. Despite this, the smooth and unperturbed nature of several galaxies observed by the JWST continues to challenge our assumptions. These unexpected findings open the door to alternative models of cosmic evolution, ones that may rely less on violent mergers and more on subtle processes like plasma dynamics, electromagnetic forces, or as yet undiscovered principles of astrophysics. Scientists are now re-examining long-held beliefs, using both new data and fresh perspectives to refine or even replace existing theories. It's important to remember that science evolves through such moments of uncertainty. Paradigm shifts are not signs of failure but indicators of growth. When observations contradict established theories, they push humanity toward deeper understanding. The James Webb Space Telescope has become a powerful tool, not only for observation but for provocation. It forces us to ask harder questions and to remain open to unexpected answers. As we look further into the cosmos, we also look further back in time, toward the very edge of what is observable. Each image sent back from JWST isn't just a snapshot of a distant galaxy, it's a message from billions of years ago, preserved in light. These photons, having traveled across the fabric of space for eons, now inform our understanding of where we come from, what we are part of, and perhaps where we are headed. Despite the challenges to prevailing theories, the journey of discovery is far from over. In fact, it's only just beginning. Every unexpected image is an invitation to revisit what we think we know. Maybe the Big Bang needs refining. Maybe another model will eventually replace it. Or maybe we'll find that the truth is more complex and beautiful than any single theory can contain. What remains undeniable is our drive, the uniquely human urge, to understand. We build telescopes, satellites, and theories not just to look outward, but to reflect inward. What we find in the stars helps define who we are on Earth. So, as we continue to explore, to question, and to learn, let us celebrate the uncertainty. Let us embrace the unknown. Because it is in the unknown that true discovery lies. JWST suggests that mergers may be far less frequent than previously believed. This has led some scientists to wonder whether the early universe was more stable than the Big Bang Theory allows. The detection of older galaxies that appear fully formed also raises concerns regarding the timeline of galaxy development. The Big Bang Theory suggests that the universe was initially a hot, dense point that expanded and cooled over billions of years. During this process, the formation of galaxies should have been gradual, with older galaxies being harder to detect. But the JWST has captured galaxies that appear to be billions of years old, raising doubts about how quickly these galaxies could have formed. Were they, in fact, the result of a cosmic event from the past, or is something else going on? These findings have compelled a number of scientists to reconsider alternative models of universe-wide creation, like plasma filamentation theory. This theory differs from the Big Bang theory, which states that the universe began in a single explosive event. The theory of plasma filamentation suggests that the universe was shaped by the interplay of electric currents and magnetic fields, which guided the formation of stars, galaxies, and other cosmic structures. This theory proposes that visible plasma filaments could have contributed significantly to the creation of the universe as we know it, on any scale. One of the most intriguing aspects of the plasma filamentation theory is its potential to explain the observed discrepancies in the formation and size of galaxies. This theory holds that the process of star and galaxy formation could have occurred more gradually and in a more organized manner than the Big Bang theory suggests. Rather than a sudden, violent expansion, it's possible the universe evolved through a series of processes driven by magnetism and electricity. This could account for the smoothness of the galaxies observed by the JWST, in addition to their surprising ages. While the plasma filamentation theory is still relatively young, it offers a compelling alternative to the Big Bang theory. It presents a universe shaped by more subtle forces than previously contemplated, and may provide the key to understanding the true nature of our cosmic origins. However, like any scientific theory, it will need to be tested and refined as new data becomes available. Our capacity to observe the universe keeps improving, and we may discover that the answers to these profound questions are more complex than we ever imagined. On the brink of these new discoveries, it's important to remember that our understanding of the universe is still in its infancy. We've come a long way from the early days of astronomy, when stars were seen as mere points of light in the night sky. Today, with the assistance of advanced telescopes like the JWST, we are able to look further into time and space than ever before, but there is still so much we do not know. In the coming years, as we continue to gather data and refine our models of the universe, we may uncover even more surprises. Perhaps we will find that the universe is even more mysterious and intricate than we are currently capable of understanding. Imagine, perhaps the answers to our most fundamental questions will force us to reevaluate everything we thought we knew about the cosmos. As humanity continues its journey of exploration, one thing is certain: the pursuit of knowledge will never cease. We will continue to ask questions, seek answers, and challenge our understanding of the world around us. The science of the future is bright, and we are only just beginning to scratch the surface of what's possible. So, as we await the next wave of discoveries, we recommend that you remain curious and engaged. The more we learn, the more we realize how much there is yet to be discovered. And who knows? The next great breakthrough may come from an unexpectedly challenging direction, one that reshapes everything we thought we knew about the universe and our place within it. As we conclude this discussion, we invite you to share your thoughts and theories. What do you think about the Big Bang theory and the plasma filamentation theory? Do you believe the universe is still expanding, or is there another explanation for the phenomena we observe? Join the conversation in the comments below, and don't forget to subscribe to the channel and activate the bell notification to keep up with future content. As we delve deeper into the complexities of the cosmos, keep in mind, the questions we are tackling are not only scientific but profoundly philosophical. Our efforts to comprehend the universe's origins, the nature of time, and the possibility of other forms of existence push both our intellect and creativity to their limits. Every groundbreaking discovery challenges the very foundations of what we once believed to be true. This journey into the unknown reveals not only the secrets of the universe but also highlights the very essence of our human condition, our relentless curiosity and our drive to understand the world beyond our immediate surroundings. When we speak of the universe's beginnings, we are talking about a moment far beyond our comprehension. The Big Bang theory posits that the universe began from an infinitely dense point, expanding outward to form everything we know today. This idea has shaped our understanding of cosmic history for nearly a century. Yet, as the most recent data from the James Webb Space Telescope demonstrates, the picture may be more intricate than we realized. The images and data now available to the public challenge our understanding of galaxy formation, the universe's expansion, and even the age of galaxies. While the Big Bang theory remains the leading explanation for the universe's origins, it is far from a perfect model. Finding galaxies that appear to be older and more fully developed than anticipated suggests that the process of galaxy formation may have occurred significantly faster than expected. Could it be that the universe did not expand as slowly as we once thought? The data from JWST suggests we may need to re-evaluate our current models and theories regarding how the universe has changed over time. Our comprehension of the universe is far from complete. If the expansion of the universe did not happen the way we previously believed, what alternative explanations exist? One such possibility is plasma filamentation theory. This theory suggests that the formation of galaxies and other cosmic structures was driven not by a singular explosive event, but by the interaction of magnetic fields and electric currents. This framework provides an entirely different way of understanding the creation of stars, planets, and galaxies, and it could potentially explain some of the anomalies seen in the JWST's first images.